Hey guys, we shall try to solve some problems on finding step response of a LTI system. So we have a problem here. Find step response of a system with impulse response. H of n is 1 for n varying from -3 to 2 and equal to 0 otherwise. So basically, one of the way to represent a system is actually in terms of impulse response. Whenever we say impulse response, it says something about the system. Okay, just think like that. H of n, whenever we say impulse response H of n, it is nothing but a system. Okay, it is one of the way to represent a system which is in terms of impulse response. Fine. So I have a system with impulse response H of n and I have to find its step response. Okay, so solution. First we'll try to sketch this impulse response H of n. So I have n, so n is varying from where to where? So -3, -2, -1, 0, 1, 2. And what is its amplitude? 1 everywhere, right? So everywhere it is 1. From n varying from -3 to 2 and equal to 0 otherwise. So for other values of n it is 0. So its amplitude is 1. So what is this? This is nothing but impulse response. It's a system, okay? Now I need to find its step response, and in the previous video we have derived the equation to find the step response of a discrete time system, and it says something like this: S of n, small letter s of n is nothing but the step response of a system, is equal to what? Summation k varying from -infinity to n h of k. So this is the equation we derived, right? Fine. And also we called it as running sum of a impulse response, that I will try to convince you in this problem. Now, so the thing is, we in the equation we have impulse response in terms of k. The independent variable is k. So what do we do? The way we did in convolution sum problems, we are going to change the independent variable of h of n to k. Okay. So instead of writing in terms of h of n, we will write it in terms of h of k. Fine. So let me plot again just by changing the independent variable. So -3, -2, -1, 0, 1, 2. Now this is k and this is h of k and its amplitude is 1. I just changed the independent variable to k. Okay. Why I did this? Because in the formula it is in terms of k. Fine. So k takes the value from -infinity, right? Just look at the formula. K is varying from where to where? -infinity to n, right? So k takes a value from -infinity. Where is -infinity? Somewhere we cannot reach, right? And where does it end? It ends at n. Okay. And what is n? N is actually, it has a liberty to move from -infinity till +infinity, depending upon it's my wish. Wherever I want, I can keep this n. Okay, starting from where? -infinity. If in case in this particular problem, if I keep this n at say k is equal to 0, this will be my slider with an index n. Okay, so if I keep this n at k equal to 0, so this n is where starting from where? It is started from -infinity. And what I have to do, I need to sum up all the samples of h of k starting from -infinity up to n. And what is the n value? It is 0. Okay, I hope you got the concept. For example, if I keep this n at 2, so what will be the summation limit now? K varying from -infinity till 2. I need to sum up all the samples of h of k. Fine. Say if I keep this n at somewhere 10, is it possible? No, right? Why? Because my k ends at 2. I cannot reach more than 2. Even though if I keep this n at 10, so after 2 everything is 0. It does not matter actually. You can keep it at 10, but the samples are 0, so that summing up does not count. Fine. Okay. Let me just tell you what's happening here. Later on we'll take up the problem. We will solve the problem actually, but this is also, I'm solving the problem here, but I'm showing you what's happening actually in this case. Fine. Say if I put n is equal to -3, so what happens? if this slider is at -3, right? It's something like this. So it's -3, -2, -1, 0, 1, 2. So this is okay. What is S of n? S of n is nothing but I need to sum up. It's a running sum. Okay. So starting from -infinity till n, I need to sum up all the samples of h of k. Fine. So if I put, now what is S of n? S of n is nothing but S of, what did I put the n value? -3, right? S of -3 is equal to what? So starting from -infinity, I need to sum it up. So from -infinity till -2, it is completely 0. Oh, sorry, till -4 it is completely 0. But I have a sample only at n equal to -3, which is 1, right? So it is 1. Now say if I put, say n is equal to -2. Now where will be my slider now? Slider will be at here, right? It is at here. Fine. Now what is S of -2? What is S of -2? S of -2 is nothing but, so what I have to do is I have to sum it up from k varying from -infinity to -2, right? So this is nothing but till -4 it is 0. So -3 sample plus -2 sample. -3 sample is 1, -2 sample is 1. So 1 plus 1 is 2. Okay, at n equal to -2. So if I put n equal to -3, what is S of -3? Now this goes to, sorry, n equal to -1, S of -1, this goes to -1. Now what is the running sum? So till -4 it is 0. So -3 sample plus -2 sample plus -1 sample. So 1 plus 1 plus 1, which is 3, right? Say n equal to 0. What is S of 0? Which is nothing but 1 plus 1 plus 1 plus 1, which is 4. Say n equal to 1. What is S of 1? Which is nothing but 1 plus 1 plus 1 plus 1 plus 1, which is 5. So n equal to 2. What is S of 2? It is 6, right? Because 1, 2, 3, 4, 5, 6. So depending upon where you keep this n value, my step response is actually the running sum. Fine. So ultimately I can write it as S of n is equal to, at -3 it is 1, at -2 it is 2, at -1 it is 3, at 0 it is 4, 5, 6. Okay, so where should I keep the arrow mark? At n equal to 0, and it is at 4. So this is the step response of the system h of n, of the system represented by the impulse response h of n. Right? This is what actually happening. It is just the running sum of the impulse response, and this running sum depends upon where I keep this n. Fine. So h of k is what? It is 1 for it is 1 from -3 to 2. So -3, -2, -1, 0, 1, 2. This is k, and everywhere it is 1. Right? Now S of n, step response formula, summation k varying from -infinity to n, h of k. Okay. Now h of k is varying from where to where? It is varying from -3 to 2, right? Okay. And what is its amplitude? 1. So what I do in the k, I'll replace, I'll change the limit. It is from -3 to 2, but I cannot put the end value 2. It depends upon where I keep this slider n. It start from -3 and end set depending upon where I keep this n value. And I can maximum I can keep this n value at 2, right? I can not go beyond 2. Okay. S of n is equal to summation k varying from -3. Okay. Why did I write -3? Because signal starts at -3. Okay. And n. Fine. You might ask me, sir, why did not you put 2? Because signals ends at 2. I cannot put 2 because formula says that the upper limit is n, and this n has the liberty to move from -3 to 2. I can keep at -3, I can keep at -2, I can keep at -1, dot dot dot, I can keep at 2. Fine. And h of k. And what is the value of h of k? It is 1, right? So I'll write this as 1. Fine. Because from -3 to wherever I keep, it is actually n. Fine. Now I need to simplify this. this lower limit I need 0, and I have explained you how do we bring this lower limit to 0, right? So how do you bring it? You just take this to the left hand side and equate it with a dummy variable, right? So if I take this to the left hand side, what happens? K plus 3 is equal to, I'll equate it with a dummy variable of m and write this in terms of k. So what is k from this? K is nothing but m minus 3. If I take this plus 3 to other side, it is minus 3. Now in this summation, wherever k is there, you replace it by m minus 3, right? So this is k varying from minus 3 to k varying from n, right? So what happens here? So s of n is equal to summation, so k, but what is k? M minus 3 equal to what? Minus 3 to k, which is m minus 3 equal to what? N, and it is 1, right? Here it is 1. So minus 3 plus 3 cancels out, and if I take this minus 3 to the other side, what happens? S of n is equal to summation m varying from 0 to what? N plus 3, 1. Fine. Now we have a standard equation, summation n varying from 0 to n 1 is nothing but n plus 1. Okay, fine. Now this entire thing I will consider it as n. So what happens if I apply this standard result here? So s of n is equal to what? This is what? N plus 1. So n plus 1 is small letter n minus 3 plus 1, which is plus 1. Fine. So s of n is equal to what? N plus 4. Fine. And there is a limit to put the values of n. From where to where I can put the value of n? From minus 3 till where I can put 2. Other values of n, this equation is not valid. Okay, we'll cross check it. Say if I put s is equal to minus 3, I am here. Now my n is here. Okay, so what is the running sum? So 0 0 0 0 0 0 plus 1, which is nothing but 1, right? Is this 1? See, put this value here. So n is what? Minus 3, which is minus 3 plus 4, which is equal to 1. When I put n equal to minus 3, right? So s of, when I put n equal to minus 2, what happens? N is minus 2 plus 4, which is equal to 2. If I put minus 1, it is minus 1 plus 4 equal to 3. If I put 0 plus 4, which is equal to 4. If I put 1, so 1 plus 4, which is equal to 5. If I put 2 plus 4, which is equal to 6. If I put 3, what happens? If I put 3 here, what happens? So 1 plus 1 plus 1 plus 1 plus 1 plus, still it is 6, right? If I put 4 also, it is 6. Fine. Depending, the thing is, no, I cannot limit this. So n takes the value, because it is 5. So this, instead of writing this, I can write it as n is greater than or equal to minus 3. My n takes the value greater than or equal to minus 3. Even if I put n as infinity, what is the value I get? It remains constant at 6. After n equal to 2, if you give 3, I have 6. If you put at 4, I have 6. 5, I have 6. 100, I have 6. Till infinity also, I will be having 6. Okay. So therefore, the step response is nothing but n plus 4, and for n greater than or equal to minus 3. So this is the step response of a system h of n. So if you are still in confusion, if you didn't get the concept, I will take a few more problems in the next videos so that you will be convinced.